For centuries, whales have been the inspiration for countless myths and legends, and none more so than the narwhal. One of the marine world's most mysterious creatures, it has no dorsal fin, prefers the cold waters of the Arctic, and is the only aquatic mammal with a single tusk. Narwhals are found in the Arctic waters in Canada, Greenland, and the European Arctic. In Nunavut, there are two populations, one in Baffin Bay and one in the northern Hudson Bay. The Department of Fisheries and Oceans and colleagues from Greenland, Denmark, and the US have been studying the narwhal for over 15 years.
My name is Pierre Richard, and I'm a research scientist with the Department of Fisheries and Oceans in the Arctic Aquatic Research Division. And my specialty is working with toothed whales in the Arctic, which are the narwhal and the beluga. The narwhal is a medium-sized whale, so it ranges up to 20 feet long. It's an ice-adapted whale, which means that it doesn't have a dorsal fin, for instance. And it lives year-round in the Arctic environment, most months in ice. Very unique feature that it has this tusk that comes out the upper jaw.
The DFO provides scientific advice for the co-managing of the narwhal population and for the protection of their seasonal habitat.
My name's Jack Orr. I'm with the Department of Fisheries and Oceans, and we're up in the Arctic in Nunavut. We are responsible for the well-being of the narwhal. In order for us to make sure that these populations are healthy and that are staying the same or increasing, we have to know a lot about their behaviors. Because they travel to different areas at different times of the year, they're subjected to different things through industrial development, ship traffic, and those things all influence the population status, the health of the population.
Long revered by the Inuit as a creature of cultural significance, the act of hunting as a group is a cultural tradition that is essential to the social structure of the Inuit. An important part of their diet, a traditional meal of narwhal skin and blubber, is nutrient-rich, providing vitamin A, C, and D in a region where growing fresh fruits and vegetables is impossible. Currently, the DFO is conducting research by tracking and recording the dives of narwhal using satellite-linked tags attached to the whales. This method allows biologists to study the animals over several seasons and in places where narwhal are, for the most part, inaccessible by any other means.
We've been tagging narwhal for about 15 years now. The tagging operations are for us to find out more about the movements of the narwhal, as well as some behaviors like diving, which we can relate to feeding behavior. And narwhals are moving around a lot throughout the season, so we want to find out where they migrate to in the winter months, and that way we have a better understanding of the habitat of the narwhal and the habitat they use.
We want to know whether some areas are more used by narwhal in order to feed, and if those areas need to be protected against fishing for Greenland halibut.
Once we have the animal, we use this boring tool which we stick through the back of the animal. Then we push this nice smooth nylon, 10 millimeter nylon rod through. That holds the tag in place. We cinch it down, we crimp these collars, and it sits on the animal for up to a year. And it's much like a piercing, where if you had a heavy earring, it would slowly pull through your ear. And that's very much the same. This slowly pulls out and eventually falls off and falls to the bottom of the ocean.
While the animal is being tagged, biologists also take physical measurements and samples of blood, skin, and blubber, which provide them with essential information about the whale's health, genetics, diet, and stress levels during restraint. The samples of blubber and skin taken from the narwhal can determine what the animal has been eating and any possibly hazardous contaminants the narwhal may be ingesting. The tagging process is completed as quickly as possible to reduce the stress on the animal.
Once we come back from the field, we'll monitor the movement of the animals from our computers. The instruments that we put on their back are emitting when they surface, and they're sending a signal to a variety of satellites that can capture those signals. Those signals are sent back to receiving stations on the ground, and we have access on our computers to the results.
Dr. Martin Nuia is also studying the narwhal's tusk and the purpose it serves.
We looked at the surface of the tusk and found tiny openings throughout its entire surface, roughly 10 million of them over an 8 to 9 foot long tusk. These were openings that connected the ocean environment to the inside blood and nerve supply of this tooth that could possibly send information from the environment to the brain.
By applying salt solutions to the tusk, he has been able to observe the narwhal's reaction to various simulated environments.
When salt solutions that were higher than normal were introduced to the tusk, that the heart rate increases, that brain activity changes. And again, when the fresh water was introduced, same thing. Changes calmed with the heart rate. Changes in brain activity were monitored. These are the pieces of the puzzle, the scientific pieces of information that we need to show that there's a sensory link between this tusk and the narwhal.
The DFO research is heavily dependent on a cooperative and respectful relationship with the Inuit of Nunavut. Without the expertise of local hunters, it would be more difficult to find groups of narwhal or suitable locations to set nets for catching the animals.
Well, it's important to engage the Inuit in these activities for a variety of reasons. For one thing, they're the beneficiary of the resource. They'll be affected by decisions that are made over narwhal management, narwhal conservation, and so on. For them to see the work means that there's a greater acceptance of the science. And of course, we couldn't do this without them because we wouldn't know where to go exactly and the behavior of the animals. So an exchange between scientists and Inuit fosters better science and better management and better conservation for the narwhal.
The biologists also depend on the Inuit to help set up the research camp. In 2009, the research camp had 21 people, equally distributed between researchers and Inuit. For DFO biologists, it is essential to share the research findings on narwhal with the Inuit, especially those who have helped gather the data, and to all Inuit who ultimately may be impacted by the findings of the research. The DFO research will help create a more accurate population estimate and will help in understanding how various environmental and human-caused factors may impact the narwhal. The hope is that the DFO biologists' research will have a positive impact on the narwhal population and the Inuit that depend on them for their livelihood. For more information about the DFO's narwhal research, visit www.dfo-mpo.gc.ca and search for NARWHAL.